we had discussed in order for cotan. Oh, this is cotan negative, guys. You guys did tan. Yeah, because they were saying tan. It's not tan. It's cotan. It is 180. It's 180 because everyone was saying tan, but it's not tan, is it? It's cotan. And cotan is what divided by what? Cotan is, yeah, x over y, isn't it? So you want your y to be 0, right? You want your y to be 0. So where is your y 0? 180. 180. And 360. But 180 is the only one that fits in here. So it's because people were saying tan that it was confusing. If it was tan, it would be 90, but it's not tan, it's cotan. So we're looking where y is 0. Where y is 0. But it's not x. If it was tan theta, then that would be 90. Because the answers would be 90 or 270, but the smallest would be 90. Okay? Now here we want where sine, and I picked a nice one. I gave you a nice restricted domain. Majority of the time they don't give you nice ones between 0 and 2 pi. Between 0 and 2 pi is like a 20-1 question. That is being nice. So sine is negative here and here, right? Where is sine negative at? Negative root 3 over 2 at?
240 and 300.
Right, 240 and 300 because it's at what? What kind of reference angles is root 3 over 2 at?
30.
At 30s, right? So,
60?
60s. I was like, your answers won't work for 30s. It's at 60s. So we go theta equals, and in this one you have theta equals because we're solving for theta, correct? And that's at 240. And what's the other one? 300. Yep. I'm just giving the answer in 240 and 300, which is true. And then we always have to check our restricted domain. And if our domain's in radians, our answer has to be in radians, right? You can write degrees, not a big deal, but you can't stop there, right? So 240 is, what's it going to be? 4 pi over 3, and 300 is 5 pi over 3. Yeah. So make sure you box one that's in radians. Okay, tan theta equals 0. Now remember, tan theta equals 1's at 45s, right? Because that's where your x and y's are the same, is at root 2's and root 2's. So 1's a negative, 1's at 45s. Tan theta equals 0s and undefined at the axes, right? Now in order for tan theta to be 0, tan theta is y over x. How can I get something to equal 0? What has to be 0, the y or the x? The y. You can't divide by 0, can you?
No.
So this could be any number, but the only numbers we have options for are plus or minus 1, technically, correct? So where is y? 0, and x is plus or minus 1's at? At x, at your x-axis, which is? Pi and 2 pi. And it includes the 2 pi because this has an equal sign. Watch though, because sometimes they won't put equal signs under there. Then if you give 2 pi, you're wrong. Correct? So theta would equal pi and 2 pi. And then for tan to be undefined, that means tan theta has to be, well, it's the y over x. My x this time has to be 0, and this could be plus or minus 1, couldn't it? So where is x equal to 0? At 90 and 270, or what is that in radians? Pi over 2 and 3 pi over 2. And these ones you'd have theta equals because you're actually finding the angle. So you're finding the inside of the unit circle. Yeah? Wouldn't B include 0? Inclusive? Yep. I'm going to that hurts me to do that, but the zero should, it doesn't matter. It can be out of order, but that bothers me. But yes, absolutely. It should be at 0, pi, and 2 pi. Yeah. Determine the exact value of cos 150. Cos 150 is here, which means if it's cos, it's an x, and x is negative there, and it's negative what?
3/2.
Okay. Sine of negative 30. Okay, so this is the same as sine of 330 because you can just add 360 to it. And at 330, sine is what? Negative 1/2. Cos squared 225 is the same as saying cos 225 squared. The reason why I ask is sometimes they give them, but also because the squared comes up in calculus. So it's just a pre-thing. Okay, cos 225. At 225, cos is what? Negative 2/2. And then I have to square that. Square a negative becomes a positive. Square a square root, it drops it off. Square a 2 and it becomes a 4. Reduce that, it's a 1/2. Sine 5 pi over 3 is in quadrant 4. So it's here. It's more like here. It's the y. What's the y? Negative 3/2. Cos of negative 5 pi over 3. In order, if we wanted to get it to land on the unit circle, we'd go negative 5 pi over 3 plus 2 pi, which is negative 5 pi over 3. Multiply by 3, multiply by 3. We get plus 6 pi over 3, which is pi thirds. So we're looking for cos of pi thirds. What is cos at pi over 3? Positive 1/2. And then tan 2 pi over 3 squared. We have to find tan 2 pi over 3 first, which is y divided by x. Y at 2 pi over 3 is positive, what? Root 3/2. And then x is negative 1/2. Flip and multiply. So we get negative root 3. That's what this is. But I need to do what to it? Square it. Square a negative becomes a positive. Square a square root, it becomes 3. Every 60-degree reference angle, tan will be root 3, right? Positives or negatives depending on cast rule. Every 30, it's going to be root 3/3. And then cotang's just the opposite, right? Because it causes it to reciprocal. It's reciprocal. Okay, we're going to go to the notes. We're going to put on some serious thinking caps. Okay. Yeah. Same section. So, amplitude is plus or minus a in your equation, correct? In your equation, your amplitude could be positive or negative a, because when I find the amplitude, I take the absolute value of a. We agree? So off an equation, your amplitude is really easy. You go to your a and you take the positive off of it, or you take the vertical stretch. The vertical stretch wouldn't count the positive or negative sign anyways. But your amplitude off of a graph, the way you figure it out, is you actually do the absolute value of the max minus the min divided by 2. When you do that, it actually finds that the distance between, half the distance technically, between your max and your min. That's all you're doing, right? Absolute value of max minus min divided by 2. So we're going to practice that on a whole bunch of graphs that are on the paper in front of your face. We're going to find all the amplitudes first. Then we're going to go find all the periods of the graphs. Then we're going to find the midlines. Then we're going to do the horizontal phase shifts last because they're the ugliest. Okay? So let's go down here. We're going to find the amplitude of this graph. Well, the amplitude is the absolute value of the max minus the min divided by 2. And you can use this formula whenever you're finding the amplitude off a graph. Off an equation, it's just the absolute value of A, right? Off a graph, it's the absolute value of max minus min divided by 2. So, it's going to be the absolute value of, what's my max? 10. Minus my min, which is negative 10. That's value divided by 2. So it's going to be the absolute value of 20 divided by 2, which is 10. Now, does that make sense? From min to max, it's a distance of 20, and the amplitude is half, right? So instead of using the formula, you could just count your distance from min to max and divide it by 2, couldn't you? Takes me 10 to get to here and 10 more to get to here, which is 20. That's a distance of 20. Divided by 2, my amplitude is 10. So if you count up 10 and you count down 10, they should meet at the same spot, do they? Then you know you're right. Okay? Yeah, I found my amplitude. Okay. I'm going to go to our next one. This one here. We're going to do our amplitude. So we're going to do the absolute value of the max. What's the max? 2 minus the min, which is, and then I'm going to divide it by 2. So I'm going to get the absolute value of 4 divided by 2, which is 2. Does it make sense? Well, let's count it up. If I count up 2 and I count down 2 for my max, do they meet at the same spot? Yep, we're good. Okay, flip over. We're going to do the amplitude. This one looks very similar. So we do the absolute value of the max, which is 2 minus the min, which is divided by 2. So I get the absolute value of 4 divided by 2, which is 2. If I count up 2 and I count down 2, they meet at the same space. You do this one. Find the amplitude of that one. The next two, you can find the amplitude for 3 and 4. I seem to have missed putting example 3 on 3. Example 3 is not enough. So do the last 2 graphs. So for this one, I got 3. Bless you. When I count up 3 and I count down 3, they meet, correct? Okay. And I'm drawing the arrows for a reason. You'll see why when I go up 3 and down 3. And then for this one, the absolute value of the max, which is 3 minus the min, which is negative 3, divided by 2, which is 6 divided by 2, which is 3. So I count up 3, count down 3. And they meet. Great, we have the amplitude. What does the amplitude give us in an equation? The A value. On cosine sines, doesn't it? It actually gives us the positive and negative of it. So let's go back. We're going to start doing the equations for these ones. Back right to your first one. So, how many equations are we going to get from this graph? We're going to have 4. We're going to get a positive and negative sine and a positive and negative cos, aren't we? Because our A can be plus or minus for both of them, can't it? And these graphs that do this are cosine and sine graphs. So we can actually get 4 equations. Now, if they don't specify which one, you could pick any equation to give an answer, correct? But what they could say is determine the equation in the form y equals a cos b x minus c plus d, where a is greater than 0. So they want the positive cos equation. So it's in our best interest to learn all 4, then they can ask us whatever version we want, and boom, we can get any one of them, right? So we're going to go down here. We're going to have y equals, my a in this one was a 10, correct? So I could go 10 cos, y equals negative 10 cos, y equals 10 sine, y equals negative 10 sine. Because my amplitude is going to be the same for all of them, isn't it? So I find my amplitude one way, and then I can do 4 equations with it, can't I? So now we're going to do the same with the next one. Ooh, that was not good. I don't know what just happened. Delete all of them? No. All right. I did kind of. So I'm going to, this amplitude for this one is 2. So now I'm going to go y equals 2 cos. Y equals negative 2 cos. Y equals 2 sine. Y equals negative 2 sine. Then I'm going to flip over. Notice the pattern. We're going to just keep doing that. So for this one, it's 2 again. So I'm going to go y equals 2 cos. Y equals negative 2 cos. Y equals 2 sine. Y equals negative 2 sine. Next one, I always start with coses. This one has a 3, so y equals 3 cos. Y equals negative 3 cos. Y equals 3 sine. Y equals negative 3 sine. And this one is a 3 again. Y equals 3 cos. Y equals negative 3 cos. Y equals 3 sine. Y equals negative 3 sine. Okay. So our amplitude we find gets us our A. Very easy, correct? Okay. Now, the next thing we have to do is the period. Now, the period is the horizontal distance from a max to a max, or a min to a min, or a min to a max times 2, or a max to a min times 2, right? If I go from a max to a max, then it'll repeat itself again. If I go from a min to a min, it'll repeat itself again. If I go from a max to a min, that's halfway, right? So I just have to find that, the horizontal distance, and times by 2. Or a min to a max, that's halfway, times by 2, right? Okay. So let's look on this one. Sometimes it's also easier to just go from the y-axis past a max min back to it. So you just have to go till it repeats itself. So this one here, if I start on my y-axis, I'm at a max, correct? Now I just need to go to another max. So what's the horizontal distance from here to here? 4 pi, isn't it? Okay, good. The period's 4 pi. Yay. Because I went from a max to a max. Is that my b value? Before you all keep going so fast. Is that my b value? Does b equal p and p equals b? No, because Paula would be Paula and Paula would be Paula, and she isn't. So, p equals 4 pi is what p is, but I need b. How do I get b? Yeah. Yeah. The formula for b is 2 pi divided by p. So I'm going to go 2 pi divided by 4 pi. So what is my b actually? 1/2. The pi's cancel. So can I go put my b's in all my equations? One half. Did my b's change on any of them? No, when you find one b, you got all the b's, right? Okay. Let's go to this one. So we could go from a max to a max if we want. This would be 0.75 to, I don't know, 2.5. Or could we go from here? Let's watch. Go from our y-axis. We could go past a max, past a min, and back up to that same height, couldn't we? As long as we go past the max and past the min, we have to go past them. How long did it take us to get there? 2 pi. It's actually easier to do it that way than to go from a max to a max and min to min. Sometimes those are not the easier ways, right? So this one has a period of 2 pi. I start at the y, go past the max, past the min, back to that height. It's from 0 to 2 pi. So it's a horizontal distance of 2 pi. My period's 2 pi. What's my b?
1.
1. It hasn't stretched. There's no stretch, right? But we can figure it out by actually filling it into the formula if we want. 2 pi divided by p. So it'd be 2 pi divided by 2 pi, which is 1. Remember, by your horizontal stretch factor, you can do these too. Like, it should make sense, not just memorize. So my b's are all 1. Right? So I could go in and go 1 x, 1 x, 1 x, 1 x. And b's will all be the same. And they come from the period, but the period doesn't give me b. The period helps me get b. Right? And when the period's 2 pi, that means there's no b. b is 1, because it hasn't stretched at all. Because it's the same as the original. Okay, I don't know where I went with this one. Let's go up here. Oh, that is the same one. Okay, let's go down here. So this one, it's actually easier to go from a min to a min. What is that distance?
2/3 pi.
What's 0.67? 2/3, right? So we could just go 0.67. It's kind of rounded. But it would be 0.66666, let's say. Okay? So it would be 2/3. So P would equal 2/3. So B would equal 2 pi divided by 2/3. The moment I divide by a fraction, I don't stack them. That's not helpful to me, right? When you divide by a fraction, it's always better to write side by side. Because what are you going to do when you divide by a fraction? Multiply by its reciprocal. So we're going to get 2 pi times 3 over 2, which is actually 6 pi over 2, which is actually 3 pi. And you're completely correct. That axis didn't have a pi in it, so we can't add it a pi, right? Sometimes the axis isn't in radians with a pi. It might just be in radian measure. When we get to word problems, it's for sure going to be in time. It'll be like 1 second, 2 seconds, 3 seconds, 4 seconds. There's not going to be no pi's. Okay? So my b is actually 3 pi. So I can go to my equations, and I can go 3 pi. 3 pi. 3 pi. Right? Doing nothing crazy here. Doing the same thing over and over. So let's go to this one. So this one can be from a max. If I can go from the y-axis, I go from the y-axis. It's easy, because then it's just 0 to wherever, right? So the horizontal distance is easy to find. So this is from max to a max. What's the distance on this one? Horizontally. It's 4. 0 to 4, right? So it's 4. So the period is 4. So my b is 2 pi divided by the period. So it's going to be 2 pi divided by 4. So what's it going to be?
1/2 pi.
1/2 pi. Yeah, or pi over 2. 1 pi over 2 or just pi over 2, right? So we go to b, and I'm going to go pi over 2. One more. So this one doesn't start at a min or a max, it starts here. So I have to go past a min and a max, get back to that spot, correct? It could be max and min, or it could be min and max, but you have to go past one. So I'm going to go past a min, past a max, back to that spot. So where's this one happen at? 4. So it goes to 4. So the period's 4. So B is going to be 2 pi over 4, or pi halves again. What follows? What is D? What is the D? What does the D give you? D gives you the... It gives you the vertical displacement. Yeah, but it also gives you the midline. Remember, it's the midline, because I go D plus amplitude, D minus amplitude to get my max and my mins from yesterday. Remember that? So D is your midline, isn't it? There's 2 ways we can find it. We're going to go right back to the front page. So it's the line that cuts the graph in half, correct? So it's literally just the average. It's the average between your max and your min, isn't it? It's like if I found the average of your marks, that's the midline. It's the average of the max and the min. So how do you find an average? You add the 2 of them and divide by 2, and they'll get you the middle, correct? So that's how we can use the formula max plus min divided by 2 to get our D, our midline. So we're going to go max plus min divided by 2. So our max is 10, our min is 10. So we're going to go max plus min divided by 2. So we're going to go 10 plus negative 10 divided by 2. This one doesn't have an absolute value sign. Why not? Amplitude's a distance. It has to be positive, right? Does my midline have to be positive? No, my middle line could be at -3 or -2, right? It could be way below. So we don't do absolutes. So this one's at 0. Does that make sense? Where do my 2 arrows meet? It just ran out, sadly. Sorry. They're meeting at y equals 0, aren't they? So you can either use the formula, or you could literally draw your amplitude up and your amplitude down, and they should meet at your midline, should they not? So you can just draw your amplitudes, and they should meet at your midline as well. So D is 0. So we're going to go plus 0, plus 0. Do I really have to write plus zeros? No, I'm doing it for effect, so that you can see it. Plus zeros. Because your midline is just at 0, right? The middle line of the graph. So we just can go plus 0, plus 0, plus 0, plus 0 at the back. We didn't do the horizontal phase shift yet because it's the hardest part. Okay, plus zeros. Do you see that? See how we got that? Max plus min divided by 2? Or where the arrows meet, your amplitudes meet. So let's look at this one. So this one is 2 and -2. So my max is at 2, plus my min, which is at -2, divided by 2, which is 0. If it's 0, your graph should be symmetrical about it, right? About the x-axis. So let's see, where do they both meet? If I drew up 2 and I drew down 2, they met at y equals 0. Please draw your midlines like I'm doing, because this will help you with your horizontal phase shift for sine graphs. Always draw your midline in. We're going to draw our midlines. So it's at y equals 0. And it will help us with our horizontal phase shifts, I promise you. So our midline is 0. So we're going to go plus 0, plus 0. We don't really need to do this, but I'm doing it for effect to show you that there actually is something back there. It's just nothing. Okay? Plus 0, plus 0, plus 0. Now we're going to go to our next one. This one has a midline of 0 again because it's symmetrical. So it's 2 and -2. Are our midlines always going to be 0? No, I just happened to pick quite a few graphs that were symmetrical because they actually cut nicely, but I wanted a few that weren't. So we'd go 2 plus negative 2 divided by 2, which is 0 divided by 2, which is 0. So these are all plus zeros at the back. And make sure you draw your midline, okay? Go up and draw your midline on every single graph, because drawing your midline is going to help us with our horizontal phase shift of our sine graphs. Horizontal phase shift of our sine graphs. So I'm going to go up here, I'm using red. The next one's not going to be y equals 0, because the graph's not symmetrical about the x-axis, right? So our max is at -1 and our min's at -7. So we're going to go our max, which is -1, plus our min, which is -7, divided by 2, which is -8 divided by 2, which is -4. So I'm going to get -4 as that horizontal line, right? I'll be right back to there. So where are they meeting at? They met at -4, so that's good. See that? And then, instead of zeros at the back, I'm going to have -4s. Yeah. Okay. The last one's at 0 again. After this is where major thinking caps have to be put onto our heads, because the horizontal phase shift is where life gets a little more rough. But as long as you pay attention, you'll come out and think it's really easy. If you don't pay attention, you may be lost. Okay? So it's either people find it really easy or they're lost. There's usually no in-between people, one or the other. Okay? I believe you will be the people who will get it. I trust. Okay, so we're at 3 and -3. So we're going to go 3 plus -3 divided by 2, which is 0 divided by 2, which is 0. Honestly, most people get it, so I believe you will. There's very few who are actually lost. I believe none of you will be lost. So we're adding zeros. So once again, our midline is at y equals 0. Okay. Are you guys ready? Thinking caps? Major thinking caps? Okay. Put down your pens, pencils, everything. We're just thinking caps here. Okay. So we're going to go. You don't have to touch your calculators. You're just paying attention to what I'm doing. So we go cos x. I'm just putting in the positive cos x graph. Just the positive cos x graph. We agree? Okay. Not the negative, the positive. And the positive cos x graph looks like that. We agree? Okay. So, the y-intercept, what's on the y-axis for a positive cos? What is on that y-axis?
On 0 and 1.
0, 1. What is it? The
maximum.
The maximum. Is the maximum on there? Do you see it? Everyone sees that? Everyone agrees with me? So if the positive cos graph, the only way stuff can move, the only way that max can move is with a horizontal phase shift. That's it. Does a vertical stretch change it? No, it would make it maybe move up or down, but the max would stay on there, wouldn't it? If it reflects, yes, the change is going to happen, but it can't reflect because I'm using a positive cos, correct? Okay, what about a vertical translation? Will it move it off there? No, it'll move it up or down, won't it? What about a horizontal stretch? Horizontal stretch, my x there is a 0. So is it going to change it? No. What's the only thing that can move that maximum? Horizontal phase shift. The horizontal phase shift of these is so easy to find if you remember that. If you remember that if the maximum is not on that y-axis, you have a horizontal phase shift for positive coses, you can get horizontal phase shifts super fast. Okay? So if your maximum for positive cos is not on the y-axis, you have a horizontal phase shift. We agree? So that's the only thing that can move it. So let's go look at all of these ones. We're just doing the positive cos horizontal phase shifts right now, nothing else. Just the positive cos horizontal phase shifts, nothing else. Don't touch the other equations, okay? So let's go back to the first one.
Which is 0, right?
It says here, when cos is greater than 0, we look for the closest maximum, right? Oh, where's the maximum?
And
But is it on the y?
oh yeah.
Is there a horizontal phase shift at all for my positive cos? No.
So it goes to 0.
So I'm just going to go this. Do I really need to write a plus 0? Because I've just left it as an x?
Yeah.
Yep. Boom. Did my horizontal phase shift. Life is good. Easy. If I had a choice of what equation to write, I would be writing a positive cos because the max is on the y. Right? No thoughts. That's what I would do. If my max is on the y and I have a choice, I'm picking a positive cos graph because I have a horizontal phase shift of nothing. I'm just writing x. So let's go to the next one. All right. Dag nabbit, my maximum is not on there, is it?
Is it positive 3/4?
This is not a straight line drawn. But yes, it would be 0.75 pi, correct? Where was it supposed to be if I didn't have any transformations? It's supposed to be on the y-axis. It is now to the right. So what am I going to do? You guys are really into fractions. You can write 3/4 pi, or you could just write 0.75 pi. There's no, it doesn't matter, right? But I have to subtract it because I'm moving to the right, correct? I moved to the right, so I have to subtract it. Make sense?
Well, it depends how you look at it.
They'll ask for the closest shift.
Oh, okay.
So you can give a few answers. You absolutely can. You could go use the left one as well.
Yeah.
And then give that to the left. You could. They'll usually often ask for the shortest shift.
All right.
But they could do it. They could trick you and they could give you the other option. Absolutely. They can. Okay. Let's go here.
Yes.
Yeah, see, you can pick
I'm
different
not
ones.
stupid yet.
So if we
I wouldn't say.
So if we look at this one, is my max on it? Is my max on it? No. My max is, I can give this one or this one. Which one's correct? The one that the multiple choice answer matches. Or the one that the numeric response answer matches. Because they might say x minus c, and then you have to pick it going to the right. Or they might say x plus c, and you have to pick c going to the left. So you have to fit it to what they give you. That's the trick of these. Yeah? Okay. So I'm going to choose it to go right. So I'm going to go minus 0.33. But if you put plus 0.33 and I left this open-ended, you'd be right. Correct? Both of them are actually correct. I just chose to pick the one to the right. If you put plus, yeah, you'd be fine.
Would you get docked marks if you turn decimal into a fraction?
Well, this one wouldn't actually be a third because 0.33 isn't a third. It's 33 over 100.
Okay.
Yeah. Okay. The 0.75 one, you'd be golden because that was 3/4.
So
But
what's
0.33.
Okay, but you could,
You have to put
if
0.33
it
pi?
Yeah. No, there's no pi.
Oh, right, true.
It's just 0.33.
but like,
You could go 33 over 100 and you wouldn't be wrong.
so as long as like our fraction is correct.
You could, yes. Yeah. In this case, they were meaning 1/3 and they were meaning 2/3. I know what they were doing, but if it was 0.33, you could only really put 0.33. Yeah. Okay. This one. Oh! I like this one. Why do I like this one? The max is on the x-axis.
It's still 0.
Look at this. I can just go, done. I don't have to add anything. Do I have to add a 0? No, life is good. The cos one's done. Okay. What about this one?
Minus 3
You can either go minus 3 or you can go
plus 1.
plus 1. They'll often pick the closest one, so I'm going to go plus 1 because I'm a rebel without a cause. You could go minus 3 if you're that rebel. Remember, you have to look for the sign, right? If they go x minus c or x plus c, they're pulling you one way or the other, and you have to follow it. Yeah. So I'm going to go x plus 1 because I'm going to pick the closest one. Often, or they might say that the shortest horizontal phase shift or something like that, right? Okay. I think we're done those ones, right? Okay. Boom shakalaka. So if you remember that cos with a positive a value, you look for the closest max horizontal phase shifts are easy, right? What do you think is going to happen when I reflect it, when I make it a negative cos?
Look for how far the minimum is.
So how far the minimum is, because if I go and look at, that is not what I want. If I go and look here, Put down marker Lepp. Okay. Join me. Okay, negative cos x. Without any transformations, my minimum is on there. So now I look for the closest minimum. We agree? Let's go. Let's do it. We can do it. We only have so much time. Let's fly. Okay, where's my closest minimum?
-2 pi.
Ah. Ah. The options are endless. So which one's correct? The one that matches what they ask you for, right? You could go plus C or minus C, and you have to go. Honestly, they're both the same, so it doesn't matter. I am going to go x minus 2 pi, and I'm going to make it move right. You could go x plus 2 pi, and you'd get the same answer. Now, what's the great thing about these? You can type these in. You can make your window be exactly the same as the window up here, and it should match. You should always know if you get the equation right or wrong. Correct? You should be able to type your equation into y equals, change your window to this one, and your graph should match. If it doesn't, you may noopsie. Okay. Now this one, my closest minimum is
Plus quarter pi.
plus 0.25 pi. But a quarter pi in this case would be fine. Okay. This one.
Plus 0.
This one I would pick negative cos if they gave me an option, wouldn't I? Because it's the one with no shift. I'm done. I can just move to the next question. Right? I don't have to go plus 0, do I? What about this one?
-2.
It's going to be -2 because, and even if I don't know for sure, from max to max, it's 4, so this is going to be halfway, right? So we could go -2, or we could go +2, and either would be correct. I have no idea what you just said. Oh, you're crying?
Yeah.
You're so happy. It's happy tears. No? Oh, darn it. Okay. What about this one?
-1.
-1, or they could actually use +3. I'm going to use -1 because it's the closest. And I need to go to the right.
I just like go up behind for a second here.
Okay.
Really fast, then.
Signs. Where life gets a little rough. Okay, signs are so easy if you draw the midline.
You're smart.
No. They're so easy if you draw the midline. If you draw the midline, signs are easy, I promise you. If you don't draw the midline, life is rough. Life is real rough. Okay? I'm going to show you why. So, draw the midline, life is good. So we're going to go y equals, and I'm going to go sine x. Boom. Do you see that? There's my sine x graph. Do you see it? So the middle going up. The positive sign is on the middle going up. Not as easy as max is on it or min is on it, right? It's the middle going up. That's what it is. So if I draw the midline onto this baby, I'm going to put a 0 here because that's the midline. What happens?
Oh, it's at the 0, 0.
It's where the midline meets the...
X, Y, and
It's just where the midline meets the graph. And when it's positive sign, what's the slope doing? It's going up. So all I do is I look for the closest intersection of the graph with the slope positive. Okay? Keep that in mind. Let's look. I don't want to lose you. This is where some people get lost. You will not be lost.
Is this first one +5?
Yeah. So what I do so that this is how I do no fails. This is how I do it so it never fails for me. I go to my y-axis and I bold the 2 dots that are closest to it where it intersects with the midline. So do you see this one? And this one? Do you see those? Because I drew the midline, they're really easy to find. We agree? What's this one doing? Going up. What do you think this one's going to be good for? Which is the negative sign. Yeah, that's it. If you draw your midline, life is good. If you don't draw your midline, it gets a little scary. Okay? So this one's going upwards. So it's pi to the left going up, right? So I'm going to use that. I'm going to use that for my positive sign because it's positive. slope, right? My positive sign, positive slope. So it's pi over 2 to the left. So I'm going to go plus, I was not pi over 2, sorry, plus pi. It was pi to the left, correct? So I'm going to go plus pi because where my midline intersects happens at pi. Now this one's going down, but it's where it intersects. Where's it at? Pi to the right. So I'm going to subtract pi for the which sign? The negative sign. If you draw the midline and the closest intersections to the y-axis, this is not bad, I promise you. Okay? So let's go to the next one. If I'm going to do sine graphs, I draw my midline. It's there. Then I pick my closest intersections. It's going to be here. And if my midline was drawn better than it is, it's crappy, it would be here because it's supposed to be on the y-axis, but I think I pulled it down by accident with my finger. Okay? Then I do arrows. This one is going positive slope, so positive sign, positive slope, positive sign. This one is going negative, so negative slope, negative sign. Where is this one happening at? I actually can't see. I've drawn over it. This one?
No.
This one. Oh, the positive one?
Yeah.
Okay, it's 0.25 pi to the right.
So it's negative pi over 4.
Negative 0.25 pi. Or negative pi over 4. I agree to that. Yeah. Yeah. And then this one is at
Plus 3 pi over 4.
or plus 0.75 pi because it's to the left and it's negative sloped. Do you see that? So it's positive 0.75 pi. Have I lost people? Are you lost? Are you with me? Are you in Narnia or are you here? Well, lost would be Narnia. I would like to be in Narnia. It sounds like a great place to be. Okay. We are.
Why is it right? Oh, okay. I got it.
Okay. Okay, this one, I go to my midline, correct? I go to my y-axis, correct? Then I go to my closest intersections, we agree? And I bold them. So this intersects here, this is the closest to the y, and here. And then I draw arrows to help myself. This one is a positive slope, so it's going to be for my positive sign. This one is a negative slope, so it's going to be for my negative sign, because we draw left to right like we read. Correct? That would make a negative line, positive line. You all give me the same faces, no matter how long I've taught. They're all the same face, whether you get it or not, so it's really hard to tell. You're getting this? Yes, it's good? Okay. So, this is halfway between 0.33. What's 0.33 divided by 2?
0.25.
No, that is not true.
Whatever.
It looks like a quarter.
It is not. Please don't give that an answer.
Whatever.
What?
I just did 0.33 divided by 2. That's all that is. Because it's halfway between it, right? Like if I have a min and I have a max, that's going to be halfway. Okay? My positive one is happening 0.165 to the right. So I'm going to have to go negative 0.165. That is not the right spot. Negative 0.165. And then this one, my intersections with the midline is happening 0.165 to the left. I'm excited for the next one because it's the only one that's not on, and I should have gave more examples that weren't directly on the x-axis. I do this every year and don't switch them up. It's a thing. Should change it up. Okay. This one. Whoop, whoop. Isn't it great? So I drew my midline.
Oh, it's 0.
I do my intersection. It is not 0. I go to my intersections. One is here. One is here. Do you see I'm just bolding my intersections where the midline meets the graph? Closest to the y-axis? Yeah? Okay. Then I draw my arrows. This one is going up, so this counts towards my positive sign. This one is going down, so it counts towards my negative sign, yeah? Okay. So my positive sign is 1 to the left, 1 to the left. So it's going to be x plus 1. And then my negative sign is the slope. Oh, I just touched it. Pretend it's with it. I don't want to backtrack because I'm scared what it'll do. Ha! I fixed it. Okay. Sometimes it like fixes like 8 steps back. It just feels like it does what it wants. Okay, this one is to the right 1. Negative slope. It's the right one. So what am I going to do? X minus 1. Okay. Let's culminate our brains here for a second. I know there's one more, but we're going to just go to this one. Can we go to this one? We're culminating our brains, seeing if we can put everything together. Okay. How do I get my amplitude, my A? It's the absolute value of the max in this case is 5 minus the min in this case is negative 1 divided by 2. So my amplitude is
2,
that's a 3.
3, sorry.
It's a 3, right? Which gets me my what of my equations? My A. We're going to deal with that in a second. The next thing I need is the period, because the period does not get me B, but it helps me get B, doesn't it? So the period, okay, I'm going to start here on the y-axis. I always try that first. If it fails, then I go to mins, max, whatever, right? I'm going to go past a min, past a max, back up to that height. And where did it happen at? Pi. Did my period shrink or get bigger? My period shrunk. It was 2 pi before, right? Now it's pi. Let's think about that. So the period is pi. I want B. B is 2 pi divided by the period, which is pi. So my B value is 2. Does that make sense? My B is 2. So my horizontal stretch is actually 1/2. Did it shrink by 1/2?
Yes.
Yes, I feel good about myself. I'm doing well so far. Look at this. Okay, midline. Don't know why I said that so happily. Midline. Midline is your, it's technically y equals. It's your max, which is 5, plus your min, which is negative 1 divided by 2, because it's the average. So it's going to be at y equals 2. So I always go draw that, because I need it. I need you. You're my friend. Little midline. I'm a little friend. Y equals 2. Why is the midline my friend? I need it for my sine graphs. If they ask me for cos graphs, do I really need to draw my midline? No, I don't need them. Go away. We don't need you. I draw it anyways because I'm a bit of a rebel. But, you know, one might say. Okay, so our A value here. A is greater than 0. This one's forcing me to a positive sign, isn't it? It's not giving me an option. So I'm going to go y equals, my A is going to be 3, and it's positive because it told me so. Sine, what's my B? What is my B? B equals 2. Don't question it. It tells you. It says B equals 2. Don't be like, oh, it must be a half. No, B equals 2. If I told you nothing about this and I said B equals 2, you'd be like, oh, it's 2. But because you have all this knowledge, you're like, is it a half? Is it 2? No. If I handed my grade 2 child this, she would say B is 2, Mom. I don't know if she knows what an equal sign is actually. Do they use equal signs yet? I don't know. Strange to think about it. She's in grade 2, but I don't think they use equal signs. They just write answers because they use the line. They go like 3 minus 2 line.
Oh, that's true.
Yeah.
Yeah.
See? I just thought about that. It's crazy.
That's weird.
Right? If you think about it, it's kind of wonky. Okay. We picked the closest intersection. So shabam, shabam. There's technically another one here. Okay. This is going downwards. So it ain't that one. Because it's positive. This is going upwards. It's not a pi thirds. How do I figure these out? It's between pi over 3 and 2 pi over 3, which is an average, isn't it? How do I find an average? Add them up and divide by 2. So pi over 3 plus 2 pi over 3 is 4 pi over 3 And then I have to divide by 2, which is multiplying by half. So I get 4 pi over 6. Something is going wrong. Something is going really wrong. It's going to be pi over 2. Anyways, let's go. 3 pi over 3. I really wanted it to be 4, but then it counterbalances itself. And then we're going to divide it by 2. So it's going to be pi divided by 2. Why am I dividing this by 2? Because I'm finding the average between these, right here. This is pi over 3. This is 2 pi over 3. We agree? And I want in the middle. So I want half of that. So I'm going to go pi over 3 plus 2 pi over 3, which is pi. And then I'm going to divide it by 2 to get this middle part, which is pi over 2. To the right. What's my D at? Your D is your midline. What's my D at? 2. What equation would I pick if I had a choice? What's on my y-axis?
Negative sign.
Negative sign. Look, my negative sign intersection is on my y-axis, isn't it? So if I did my negative sign, it says negative. I would go y equals negative 3 sine. My b is 2. My c is nothing. So I could go theta minus nothing. Or I could just say theta plus, what's my d? 2. This is a positive cos. Y equals 3 cos. What's my b going to be? 2. That didn't change. What am I going to look for? It's a positive cos. It's positive. Look for the closest what? The closest maximum. It's between this and this. Would I pick this one? If I had a choice, would I pick this between something that's not labeled and pi over 3?
No.
Right in the middle of this? Yeah, that's where I would go first, because that sounds easy. No, that's terrible. You could find it, though. It's between something I don't know. So I'd have to do this to this divided by 2 to get that, correct? Which is pi over 4. I would have to go 0 plus this. When you want to find something in the middle, you'd go 0 plus this divided by 2. It gets you your halfway point, right?
Okay.
Then I would have to go this plus this divided by 2 to get my new halfway point to give my answer. Would I choose this if they gave me an option?
No.
Say no.
I would say no thank you. No thank you. They could force it though, couldn't they?
Yeah.
So whenever you want a value between 2 known values, you just take the 2 values and divide it by, add them up, divide by 2. You're just finding the average. That's all you're doing the whole time, right? Okay. Now you're going to be so happy with me.
Yo, did we finish that one though?
Yo, we don't need to do that one. My point on that was, would you pick it?
No.
No, please.
So why?
Jesus. Oh, I have no numbers.
Perfect.
That's not true. That's not real.
I like
That's
that.
so not
That's
real.
Take a picture.
14 to 16.
That's not bad. That's not bad.
That's not bad, except you're writing equations for a lot of them. No, so 15 and 16 have 4 graphs that you have to come up with the equations with. However, 15 is sine equations, and then 16 is cos equations. So you're not finding 4 for each, you're just finding 2 for each. But you need the practice, because you practice this, you will not make up your, the C's are the hardest part.